The next program is stepper motor rotation control. So interface is stepper motor and rotate clockwise and anti-clockwise direction. Now for this, okay, clockwise and anti-clockwise direction. So we need a control input for rotating clockwise and anti-clockwise direction. So we'll use that switch for rotating it and clockwise and anti-clockwise direction. And the speed of the rotation can be controlled by using a delay program. So here one delay function is written for controlling the rotation speed. So delay program will simply waste the time. So after coming inside the delay program, it is going to count some value. So inside the for loop, it is simply doing this for loop operation until it is equal to count. When it is equal to count, it will come out of the delay function. So we'll see the main program. As we know, stepper motor have a 4 coils. Show that stepper motor have 4 coils, that is A, B, C, D. This A, B, C, D coil values, like if coil A is high, B is high, C is low and D is low, like coil A and B is energized, and coil, like you can energize only coil B and C. How it is rotating, that I have explained in the theory, still I'll explain here. If when coil A and B is energized, consider this is coil A and B, at that time the both the coils are energized, so this permanent magnet where south pole will be between the coil A and B. If only coil B is energized, south pole will go to the coil B direction. So like that, like when both the coil is energized, it will be in between coils. So B and C, so it will be between coils. Next, C and D, it will be in between the coils. Otherwise, wave step, that means here coil A, only coil A is energized, coil B is not energized. So coil A will be attracting the rotor. So like this, at a time only one coil is energizing, only one coil will make stepper motor to rotate. So there is one more method, like half step. It is like one coil is energized, next two coil is energized. So it will be like first one coil is energized, so rotor will be this direction, permanent magnet south pole will be at this direction. Next between these two coil, because both the coil is energized, next at this position, because only this coil is energized. So like that, half step also we can do. Now in our kit, the connection is like this. The coil A is P port 1.24, or coil B is port 125. The coil C is port 126, coil D is port 127. So in our hardware, it is already connected like to the stepper motor. So if you see the hardware in this is the ARM processor, and this ARM processor P1, 24, 25, 26, 27 is connected to the stepper motor. This is a stepper motor connecting pin. So directly we can connect the stepper motor here. So from ARM processor, this is the output. Okay. So when we are writing a program, let's see our program now. When we are writing a program, here first we have to tell the direction. Okay, I'll zoom it. Yes. Okay, we have to tell the direction. The port 1, okay, port 1, 24, 25, 26 and 27. These 4 pins I am using as a output pin. That's why I am loading 1 into that. Okay, if the direction bit is 1, then it is the output. If the direction bit is 0, then it is a input. Next, pin select 2 to ensure that uh, this is I am using a general purpose input output operation. The port 1 I am using as a general purpose input output operation, because there is more than one operation can be done using one pin. So default it is in general purpose only. To ensure that we can use this instruction, the second instruction. Next, depending on as I told, I want to do a direction in both the direction. I want to control whether clockwise direction or anti-clockwise direction. Okay, the program is to rotate the stepper motor clockwise and anti-clockwise. So I need two buttons to tell whether it is a clockwise rotation or anti-clockwise rotation. So inside the while loop, I am going to check for whether the pin number switch 16. I'll show in this. Okay, here this for DC motor I already have explained, and that switch 1, so port 1.16, switch 2 port 1.17. So I am using these two switches for my uh, for my control input for the stepper motor. It is a control input for my stepper motor. So I'll check pin number 16. Okay, so pin number 16 whether it is pressed. If it is pressed, then a run variable run is equal to 1. Otherwise, if the switch 17 is pressed, then variable run is 0. Now if depending on which switch is pressed, I mean if run is equal to 1, then 16 is pressed. So if run is equal to 1, I am doing this clockwise rotation. How I am doing the clockwise rotation? I am sending 1, 2, 4 and 8. We are only concentrating on these 4 bits, the 4 bit which is connected to the stepper motor, that is 24, 25, 26 and 27. If you see this value and find out what is the 24, 25, 26 and 27, this will be like port A is 1, all other port B, port C and port D is 0. Next, by sending 2, port B is 1, all other ports are 0. Next, by sending 4, port C is 1, all other ports is 0. Next, by sending 8, port D is 1, all other port is 0. So between these values, I am deciding what is the delay. This delay is, we cannot make it 0 because if we make it 0, stepper motor will not rotate, because the energizing time and de-energizing time is we have to give. So for that we have written here delay. The next okay, so it is doing a 1 rotation, so it will continuously rotate if run is equal to 1, because it is there inside the while loop. Okay, if run is equal to 0, then it will we are sending the same value in reverse order. So D, first D is 1, next C, next B, next A. So if you go back to our coils, yeah, here if coil A is energized, next coil B is energized, next C, next D, then it is like a clockwise direction. First D, next C, next B and next A, then it is like a anti-clockwise direction. So by energizing at a time any one coil in particular order, we can make a stepper motor clockwise and anti-clockwise rotation. So this is about the program. Now as I explained in the previous DC motor rotation program, we have to create a hex file. So the target, that is external frequency, is 12 megahertz and output we should click on create hex file, and now I am not created any new project here. I am loading the same program into the same project. So project name is, sorry, I have not created new file also. I'll create new file, save it as um, step.c. okay, I'll create it as step.c. So I have to add this step.c into the my project. Okay, so under source group, add existing group. Next, search for the step.c, that is stepper motor rotation. So I'll build it. So it is going to create the hex file. Now how to load the program? We already is wait, I think I have not seen. Okay, source group, under source group, add existing group, source group 1. We should add this step.c. okay, step.c is my program. Okay, clear? Yeah, now I'll build it. It's already built. So hex file is created, and hex file name is, one minute. Okay, so created a hex file. Next, we should open a flash magic, and using a flash magic we have to connect the kit. After connecting kit, the other settings are same, that is we lpc to lpc 2148. okay, lpc 2148. Next, comfort, to which comfort your kit is connected, that comfort we have to mention. The baud rate 9600 and interface is non-ISP, and erase all the blocks used by hex file. We have to tick on that. Browse the hex file which we have created. The hex file name is same because I am not changed the project, and verify after programming and click on the start. When you click on the start, it will start loading the program into the kit. Okay, this circuit shows the connection same as our kit. So pin number port 1.16, port 1.17 and port 1.18. There is a 3 switches. So I am showing here 3 switch, but I am using only 2 switch, 16 and 17 one. And to control the stepper motor, and stepper motor is connected to port 1, 24, 25, 26 and 27 as we are seen in our program. So I'll load the program first. Browse that program. So I have created the hex file. That hex file I'll load into this. Next, I'll run this program. So when I'm running this program, now stepper motor start rotating. You can see here stepper motor start rotating because the run variable is it may be, I'll show this, the run variable, it may be 0 or 1 initially, right? Yeah, run variable is 1, so it is doing that clockwise rotation. If run is equal to 1, it has to do clockwise rotation. Now when we are pressing the switch, then only this run variable will change. So I'll press the switch for anti-clockwise direction. Like you can see here, after pressing the switch, now stepper motor is rotating in the anti-clockwise direction. If I press this switch, Now stepper motor is rotating in the clockwise direction. I'll zoom it if you want. Yes. Okay. Now if I press this switch, stepper motor is now rotating in the anti-clockwise direction. If I press this switch, stepper motor is rotating in the clockwise direction. So what the program we have created, that is working for under Proteus circuit. So this will work for our kit also, because the same connection is there in our kit. Thank you. Okay, now we'll try the stepper motor connection to the hardware. For that, I need this flash magic. So in the flash magic, I should select the uh, device, that is LPC2148, count port is 3 and oscillator frequency is 12, and then browse the hex file. So after browsing the hex file, you have to click on the start button. Once we finished uploading, one additional connection here for the stepper motor. Stepper motor needed 12 volt. The supply given to the kit is only 5 volt, so we need a adapter. So I'll connect this adapter. It is only required for the stepper motor. So once I connected the adapter, I'll switch on to use that adapter, and stepper motor start rotating. If I press on the switch 1, it will rotate in uh, okay, switch 1 is clockwise and switch 2 is anti-clockwise. Okay, so it is working properly in the kit. Thank you.